Welcome back to my channel, students. We are in Newton laws. This video is the fourth part of Newton laws of motion. In this video, we will discuss about the Atwood machine, students. Atwood machine, you are aware of that. Here it is, one of the consequences of Newton's second law of motion, students. Actually, in today's topic, we will learn about the tension and as well as the unbalanced force to an extent. Okay, first we have to understand what is the Atwood machine is. It is a simple machine. You are studying these things from your previous classes. First we will learn how it looks and what is the principle involved in it. Okay, we can call it as the mass and pulley system also. Let's take a pulley. Okay, which is fixed from a rigid support. These kind of pulleys we will watch. In the grain markets and as well as at the wells, slot bore wells. It's a smooth pulley, students, and that too it is a massless pulley, and a string is rolling over. The string which is rolling over the pulley. Here it is the string. Okay, students. Here you must remember that the spring, that is string, is inextensible. Means it doesn't extend by the application of the force. That too it is the massless, and it must be the torsionless, and we are suspending blocks from the two ends. Okay, these are the two masses which are suspended from the other end of the string which is moving over the pulley. Let's say it is M1 and it is M2. If you apply the laws of forces, the amount of gravitational force acting on this is equal to mass multiplied with acceleration due to gravity. Okay, it's the action force. Immediately the tension will develop in the string. As you know that the tension always acts away from point of contact. It is the point of contact between the two bodies. Let's say is the tension. Okay, students. In the same way, the weight of the body. Here it is M2G. Here it is, say it is W1, it is W2. Obviously, the tension acts in upward direction. Okay. Here, acceleration due to gravity is acting vertically downwards, you know that. Here, say mass of first block is greater than mass of the second block. Okay, what does it mean? Obviously, this mass gets accelerated in downward direction, while this mass tends to move up. It is what we need to understand. Okay, it is one of the application of Newton's second law. By using this diagram, we will find the net force acting on the body. And you know that net force is the difference between the two forces. Let's say it is this entire thing as a system, and we are drawing the free body diagram for the mass 1. Okay students, FBD of M1. If you take it is the point. Okay students, weight is working vertically downwards. Let's say it is W1, and the tension acts up. I told you here W1 is greater than tension. These two are the forces. The difference between the two must be another force, W1 minus T. We have to call it as the net force. This net force provides this acceleration to the body. This net force provides the acceleration to the body. That's why it is coming down. Okay, and you can write net force F1, that is Fn, is equal to M1A, and weight W1 is equal to M1G. Now we are substituting these values in. What you get? M1G minus T is equal to M1A. Freeze it and say it is the equation 1. Okay students, now we are drawing the free body diagram of mass 2. Okay students, FBD of mass 2. If you watch it carefully, the pulley making it to move up, the string is moving up, this mass is moving up. Means what here? Tension is greater than weight of the body. It is moving up means what? Tension is greater than the weight of the body. Obviously the difference between the two gives one more force, that is T minus W2 is equal to net force. Here net force is M2A and weight is equal to M2G. And substituting these two, what we get? T minus M2G is equal to M2A. Say it as the equation 2. We are adding equation 1 and 2 now. Adding 1 and 2. Let's see what we yield. T 1 and 2 I said, M1G minus T, okay, plus T minus M2G is equal to M1A plus M2A. Okay, the same terms tan T get cancelled. What we get? G of M1 minus M2 is equal to A of M1 plus M2, or A could be defined as M1 minus M2 of G by m1 plus m2. Is the amount of acceleration of the system, students. In this way, you can find out the acceleration. Okay. Here we have one more method to find the acceleration. Directly we can find the acceleration, students. Here it can be written as, I hope you have followed, acceleration is equal to m1 minus m2g. Here let's write here, a is equal to m1 minus m2 into g by m1 plus m2. Okay, students. Here we calculated acceleration as a is equal to m1 minus m2 of g by m1 plus m2. I told you this acceleration can be calculated easily by a simple technique, students. As you know that force is equal to ma. Okay. And we can write acceleration is equal to force by mass. Here in such cases, we will write acceleration is equal to unbalanced force by total mass. Okay, students, what is the unbalanced force? Force which is acting downwards minus upwards. Obviously, the force acting which is downwards is equal to W1, W2 by total mass M1 plus M2. Okay, W1 is equal to M1G minus M2G by M1 plus M2 at G of M1 minus M2 by M1 plus M2. It's the same result what we yield here. Okay, by watching that only you can solve any problem. Let's say it is 5 kg, okay, and it is the 2 kg. Now substituting the values you will get the acceleration. Acceleration is equal to g of, let's do example. If m1 is equal to 10 kg and m2 is equal to 5 kg and take g as 9.8 meter per second square, then we can find the acceleration. A is equal to g, it is 9.8 into 10 minus 5 by 10 plus 5. Okay, 9.8 into 5 by 15. Okay, students, by 1s are 3s are 9.8 by 3. Okay, it is around 3.2 6 meter per second square. Okay, students, in this way you can find out the acceleration of the body which is rolling over the pulley. It is not yet finished at the acceleration, and we have to find out the tension in the string, the tension which is created in the string. We found the acceleration. Later we have to find the tension in the string. Okay, students, if you watch the equation carefully, we have learned that W1 is greater than T, and the difference between the two provides the net force, I said. Okay. Here we can write W1 minus T is equal to M1A. Okay, students. Then W1 minus T is equal to M1, and we know the value of the A. M1G of M1 minus M2 by M1 plus M2. Okay. And W1 is equal to M1G minus T is equal to M1G of M1 minus M2 by M1 plus M2. And tension can be had as what to get? M1G minus M1G of M1 minus M2 by M1 plus M2. Our tension can be rewritten as M1G of M1 plus M2 minus M1G of M1 minus M2 whole divided by M1 plus M2. Okay, students? Simplifying it, it is M1 square G plus M1 M2G minus M1 square G plus M1 M2G whole divided by M1 plus M2. Here these terms get cancelled. And finally we get tension T is equal to 2M1 M2G by M1 plus M2. Okay? These are the tensions and accelerations in the string in case of a Atwood machine. Okay, students? Since we are doing the Atwood machine, let's do one more example of this. Here, in the previous topic, here the pulley is fixed, and we are taking one more case in which the pulley is fixed one. Okay, let's say it's a smooth surface and we attached a pulley here. It is the massless and frictionless pulley. So students, what we are doing? We are suspending. It is a string which is moving over the pulley, and we attached a mass here. In the same way, we attached one more mass. Okay, students, let's take this one as M1 and it is M2. Obviously, the weight works vertically downwards and the tension will be in this direction here, and it's the weight which is acting vertically downwards. Okay, students, we are doing the same what we did before. Means what? We are trying to find the acceleration and as well as the tension in the string. Let's start with the equations. Here it is the body 1 and it's the 2. Okay, we're drawing the free body diagram of M1. If you watch it carefully, it tends to move downwards if and only W1 is greater than tension. As usual, the difference W1 minus T might be a net force, that is W1 minus T is equal to M1A. Okay students, M1G minus T is equal to M1A. Okay, it is the first equation students. Let's take this body. Here the tension in the string is providing the motion to the body. If you watch it carefully, weight is acting vertically downwards and it is a normal reaction. Normal reaction and weight of the body get cancels with each other. Okay students, then only one force is making the body to move. Means what? FBD of M2. Obviously it is a simple thing, it is the tension, okay, which is providing the motion to the body, and acceleration also along the same direction. Then we can write T is equal to M2A. Since weight and normal reaction get cancels with each other, only a force is acting, that is tension force, which is making the body to move. So it has the equation 2. Okay students, we are adding the 1 and as well as the 2. What to get? M1G, and substituting the value instead of adding, minus M2A okay, M1A, or it can be written as M1G is equal to M1A plus M2A. A of M1 plus M2, or A is equal to M1G by M1 plus M2. It's a way to find the acceleration. Okay, here we got the acceleration. Acceleration A is equal to M1G. Similarly, we can find the tension in tension T, as you know that T is equal to M2A and it is M1 M2G by M1 plus M2 is the tension produced in the string. Is the easiest among all students. In this way you can find out the acceleration and as well as the tension in the string. Okay students, let's do one example. Let's say M1 is equal to 10 kg. I take it as 20. M2 is equal to 10 kg. What would be the acceleration? You know that acceleration A is equal to M1G. 20, take G as 10 by 10 plus 20. 20 into 10 by 30. Okay, it is 20 by 3. 6.67 meter per second square. In the same way you can find out the tension. Tension is equal to M2 of A, or you can use this relation. M2 is equal to 10 into 6.67 means what? 66.7 Newton students. Tension is measured in Newton. In this way you can calculate the acceleration and the tension in the string. Okay students, I hope you followed the lecture. If you like this video, subscribe my channel. Thank you.